Hi, today we're going to look at the definite integral. Last section we talked about the indefinite integral, and remember it was called indefinite because there are an infinite number of solutions. You can just keep adding on a different constant. The definite integral has exactly one solution, and it's a number. So the indefinite integral was a function, the definite integral will be a number. And as we saw before in a previous video, the integral from a to b of some derivative, so f prime of x dx, equals f of b minus f of a, the difference in the function from b to a, or from a to b. The notation we use is the integral from a to b of f prime of x dx equals f of x, and then we have this long vertical bar here, and that is pronounced evaluated from. So f of x, vertical bar, a on the bottom, b on the top, means f of x evaluated from a to b, which is equal to f of b minus f of a. When we find f of x, we don't need to include the plus c at the end, so we don't need the full indefinite integral with a plus c, because when we subtract f of b minus f of a, the c's cancel. You'll have c minus c, which is 0, so you don't need to include it. So we'll do a couple examples. The integral from 0 to 3 of t squared dt. So the first thing we're going to do is find the indefinite integral. So t squared becomes 1/3 t cubed, and we're going to evaluate that from 0 to 3. So we have that vertical bar after the function, 0 on the bottom, 3 on the top, just like the integral sign from before. When I plug in 3, I get 9. When I plug in 0, I get 0. So the answer is 9 minus 0, which is 9. As our next example, we have the integral from 1 to 2 of 3x plus 4 dx. Again, we're going to integrate them individually. So 3x will become 3 over 2x squared, and 4 will become 4x. And then again, evaluated from 1 to 2. If I plug in 2, I'll get 14, and if I plug in 1, I'll get 11 over 2. So 14 minus 11 over 2 is 17 over 2. And if you want, you can write that as 8.5. That's perfectly fine. They're both equal. I just tend to like my fractions instead of decimals. The third case, we've got the square root of x minus 1 over root x. We're going to integrate that from 4 to 9. So the first thing we want to do is to rewrite our integrand using the power rule. So the square root of x becomes x to the 1/2. 1 over the square root of x becomes x to the negative 1/2. So now we have it in the form of x to the n, and we can integrate. And we get 2/3 x to the 3/2 minus 2x to the positive 1/2. We're going to evaluate that from 4 to 9. To make the evaluation easier, I'm going to change our fractional exponents back into their radical form. 9, So we get 2/3 the square root of x cubed minus 2 times the square root of x. So if I plug in 9, I'll get out 12, and if I plug in 4, I'll get out 4/3. And then I do the subtraction, and I get 32 over 3. Sometimes we need to use Usubstitution, and it is very, very important that you remember to plug back in your x before plugging in a and b. So if we look at the integral from 0 to 1 of x divided by the square root of x squared plus 1 dx, the key to this is to remember that these values here correspond to this variable. So 0 and 1 are x values. So you need to remember to, again, put our integral back into terms of x before we plug in our endpoints. So we're going to do the Usubstitution, u equals x squared plus 1, because we've got that function raised to a power. And then if we differentiate, we get du equals 2x dx. So if we want to divide by 2, because we only have x dx in our integrand, so we get 1/2 the integral of u to the negative 1/2 du, which gives us u to the 1/2. The 1/2 and the 2 are going to end up canceling, so just 1 u to the 1/2. Remember that 1/2 means the square root, so I have the square root of u, which is x squared plus 1. So the square root of x squared plus 1 evaluated from 0 to 1. And that gives us root 2 minus 1. You can leave it just like that, or if you really want, you can plug it into your calculator and you'll get something like 0.414. But I would just leave the exact answer right there. So yeah, another example, the integral from 1 to 2 of 12x over 2x squared plus 1 cubed dx. So again, we've got a function being raised to a power. So we let u be that function and let du be the derivative. So u is 2x squared plus 1, du is 4x dx. When we do our substitution, we end up with 3 because 3 times 4 is 12. So 3 times the integral of u to the negative 3 du. When we integrate that, we get negative 3/2 u to the negative 2. And again, putting back in what u is and also getting rid of that negative exponent by putting it in the denominator. I get negative 3/2 times 2x squared plus 1 squared. Again, we're going to evaluate that from 1 to 2. I'm going to pull out the 3/2, so I haven't actually put that in to my evaluation. So when I plug in 2, I get 1 over 81 times that negative 3/2. And when I plug in 1, I'll end up with that 3/2 times 1 over 9. Double negative, so that's why it's a positive, a plus sign. And it equals 4 over 27. We got 2 more examples we're going to do. So C is the integral from negative 1 to 1 of 5x cubed times 3x to the 4th plus 1 all cubed dx. So again, we've got a function raised to a power, so we'll let u be that function. And we'll differentiate. We get du equals 12x cubed dx. When I do my substitution, I end up with the integral of u to the 3 du with a coefficient of 5 over 12. When I integrate, it'll become 5 over 48 u to the 4th. And then again, I'll plug back in what u is. It's 3x to the 4th plus 1. And I'm evaluating it from negative 1 to 1. Whether I'm plugging in 1 or negative 1, the inside I get 4. So factoring out the 5 over 48, I get 4 to the 4th minus 4 to the 4th, which gives us 0. As our last example, we've got the integral from 2 to 16 of dx over the cubed root of 4x. So u is 4x, again the function that's being raised to the power. Du is 4 dx. So when I do the substitution, I get 1 over 4, the integral of u to the negative 1/3 du, which gives us 3 over 8 u to the 2/3. And again, plugging in what u is and changing it back to the radical sign, we get 3/8 times the cubed root of 4x squared. We're going to evaluate that from 2 to 16. So if I plug in 16, I get 16. And if I plug in 2, I get 4, ignoring the 3/8 in the front. So I'm going to factor out the 3/8. So I have 3/8 times 16 minus 4, which is 9 over 2. Okay, so if you have any questions about it, just send me an email. We can figure it out. And good luck.